I want to introduce Spencer. Oh, and his call sign's wrong, or his last name's wrong. I fixed it, but I guess we loaded the old one. Anyway, sorry, Spencer.
I've been called worse.
I know. I fixed it on my laptop, but I bet it didn't get saved. Anyway, Spencer is a mastermind behind the Utah Digital Network and the bridge that has been built. I'll let him explain what that does, but we're grateful to have him and his wife Sarah, who's in the back there, join us today. And we'll turn the time over to Spencer. Please join me in welcoming Spencer.
So I spent the first good 5 minutes of Kevin's announcements looking for this clicker because I thought I left it somewhere and forgot. Very much an ADHD thing. Let's see. Is that audio going to be okay? Awesome. So first of all, thank you for having me here. This is the most north I've ever been in Utah today. This is my first time into the Cache Valley. I'm very much a homebody. I could stay within a 40-mile radius of my house for a year and be totally content. So thank you to Ted and others to drag me up here. And also, if this implodes, it's Ted's fault for dragging me out of my shell. So here's what we're going to talk about today. We're going to go over some digital voice basics, what makes digital voice unique compared to analog voice. We'll talk about how myself and others have made all the digital voice modes talk together. They're all trying to speak a different language, and we've kind of forced them all to behave with each other. We will go over an example using D-Star and DMR. We figured that was fitting because that's what's used a lot up here. And then we'll talk about if analog voice has a place in the digital voice world. So a little bit about me. I got my ham license in 2008. I just turned 13. And I've spent a lot of time doing hardware. So getting my ham license in high school, I found out that you could get a degree in RF engineering, and I thought, that's what I'm going to do. And I tell people that that's kind of the exception to the rule. I know most college students going through college don't have that kind of, like, I know that's what I'm going to do, and that is probably how most college students experience college. So I went through BYU and did a bachelor's and a master's in electrical engineering, and I focused my master's on phased array antenna design, and I worked on a project that involved transmitting RF directly over fiber optic cables for a large radio telescope receiver, and this is one of the boards that I designed. I now work at a small defense contractor down in Springville, where we design multifunction radar systems for military aircraft, and I work on the antennas and the RF electronics for those. And that's an example of one of our radar pods that goes on an aircraft. That one's about, 5 feet long and about that big around. And I would love to show you what's inside of it, but unfortunately I can't. But these are some of the cool data products that we get out of the radar. Imaging, moving target tracking, change detection. I work with a lot of very smart people that are way more intelligent than me, and this is some of the stuff that we all can do together. So before we get really into the presentation, a little bit of credits. And of course, I have to put up front your club. In this digital voice exploration, your club, the Bridgerland Amateur Radio Club, has been some of the early adopters of the technology, of the repeaters, and so we want to thank you for that. Utah State has also provided a place for us to host servers, which unfortunately is having a problem. It's going to come back with me down to Utah County for some surgery. But they've allowed us some space in their data centers. And then we use a lot of different software packages that are written by other people. So we try to give them credit where credit's due. And I'm sure there's stuff on here that we're not listing. So first, digital data over analog RF. A lot of people have the misconception that digital voice, digital data over RF is sending direct ones and zeros, and it's not. Digital data over RF is sent using analog. Everything that's sent over a radio wave is sent using an analog waveform. And all the receiver electronics, like I've put up here in this diagram, and transmitter electronics, those are all designed to work in the analog world. Like I said, digital data is encoded in an analog waveform. You don't really need to know all the details in that, but some very smart people have figured out very efficient ways to do that. And there's lots of different ways of encoding that data onto a digital waveform. So what's used in amateur radio here? Who here has heard of C4FM? What comes to mind when you hear that term? Yaesu, right? I think Yaesu has done a little bit of a disservice to that term. C4FM is not something that's specific to Yaesu. C4FM is a modulation scheme that's actually kind of like RTTY in the HF digital world. It stands for continuous 4-level frequency modulation. Lots of technical mumbo jumbo. But what that means is it's switching between 4 different frequencies centered around a carrier, and uses those 4 different frequencies to represent 2 bits of data. And it does that in a special way so that FM transmitters can transmit it. Again, lots of technical stuff that goes into that. But just know that C4FM is called a modulation scheme. It's not something that's unique to Yaesu. In fact, DMR Digital uses C4FM, P25, and NXDN all use C4FM. And M17, the open source mode, if you've heard of that. D-Star uses something a little bit different. It uses something called GMSK, which is a special version of RTTY, 2FSK. So has anyone ever been curious about why digital voice has to sound digital? Why can't it sound like analog? You listen to an MP3 music, that's digital, but it doesn't sound like it, right? Well, there's constraints that we have to place on digital and the amount of space that we take up in the spectrum. So in digital voice, what we do is something called parametric signal representation. What that means is we send information about the signal and then reconstruct it on the other end. So when you send your voice, even when you're talking on your cell phone, you're not actually sending your voice to the next cell phone. You're sending information about your voice, and then the phone on the receiving end is reconstructing a representation of your voice, and that's what the other person hears. So let's do a little bit of an example of that. I want you to imagine, maybe close your eyes, imagine a red rose on a rose bush with green leaves on the bush, springtime. There's grass, there's trees in the background, and there's clouds in the sky. You have that image in your head? That sentence is 100 characters long that I just said. At 2 bytes encoding, that sentence takes up 200 bytes of data. Here's the picture. Maybe it was something close to what you imagined, maybe not. That image is 48 kilobytes or 48,000 bytes. What you just experienced is parametric signal representation. That's why digital voice sounds digital. Where you're sending information about the signal, that description, and then recreating it. And it allows us to use so much less data than it would to send the actual thing. So in review, why does it have to sound digital? We use something called a vocoder to compress the traffic. That vocoder is what actually turns the signal from what you're speaking into the parametric representation. DVSI, Digital Voice Systems Incorporated, is the commercial vocoder that's used in all the common digital voice modes. It's used for P25, YSF, and there's different versions of it. We'll get into that later. D-Star, DMR, all the fun things. A different open source codec 2 is used in M17. but it runs on the same idea. So what is cross mode? When I want to make two digital voice modes talk together, I have to figure out a way, even if they're speaking the same language under the hood, they may not be compatible with each other. So cross mode is used when the voice modes use the same codec, so that same digital representation, but the outer packaging, the outer wrapping is different. So that's analogous to, imagine you're watching a news broadcast versus reading a transcript of it, reading the news article online. It's the same content, but it's in a different format. The cross-moding maintains one-to-one audio quality, which is important since digital voice is already compressed so much. And DMR to NXDN Kenwood's digital voice is an example of that. What is transcoding? That's a much different story. So who here in the club is experienced and knows about the club's D-Star and DMR capabilities? I know Ted has been a huge proponent of that. D-Star is a little bit of a black sheep in the digital voice world because it uses a different codec than the rest of them. So the analogy to that I came up with was watching a news broadcast in a different language. All the information is there, but you need a translator in between to be able to understand what's going on. The audio quality heavily depends on how you do that transcoding. It depends on the quality of your translator. And we will go through an example of D-Star to DMR in a little bit. There's D-Star. So here's a little bit of how we've been able to put all this together, make all these digital voice modes talk to each other. And the intent behind this was that people have their preference on what radios they like to buy. Some people like Yaesu radios, which do Yaesu system fusion. Some people like ICOM and now Kenwood that does D-Star. Some weirdos like me like Motorola radios, which do DMR and P25. And so we wanted a common place for everyone to be able to come together no matter what radio they have, no matter what digital voice format, and be able to talk to each other. And that was the start of this big project to bring everything together. So what we do is we separate out our modes between the native modes, what we're saying can kind of speak all the same language, but just need a little bit of reformatting, and then the transcoded modes. So what the modes that don't speak the same language and need a translator to sit in between them and do the translating. Over on the native modes, we use something called an XLX reflector as the central hub. And over on the transcoded modes, we use something called analog reflector, which is a newer development by the guys at DV Switch. So into our XLX reflector, we can point all of the different native modes. So Yaesu System Fusion, Amcom Networks DMR, and NXDN from ICOM and Kenwood go into that directly. And the bits of software that stick them all together do that kind of frame restructuring. In the transcoded modes, everything connects to analog reflector from something called analog bridge. That's what converts analog voice into digital voice. So we have P25 that goes through analog bridge. We have Yaesu System Fusion, which kind of sticks off of that. That's a newer addition. We can put analog directly on this, like All-Star. We can put D-Star on this through another instance of analog bridge. We can put M17 through this. And everything talks together through analog reflector. In the early days of the multimode bridge, we had everything pointing into XLX. And what that meant is that some modes were getting a double hit of translation, and you lose a lot of fidelity and information that way. So in the old days, if a D-Star user wanted to talk to P25, their voice would be encoded, first encoded in D-Star, brought down to analog, then re-encoded in DMR's voice codec to go into the hub, and then brought down to analog again, and then re-encoded in P25's voice codec and sent to P25. And that was a big hit in voice quality. But just this last year, we figured out how to use analog reflector and make it so that everything only has one transcode hit to it. So D star wants to talk to P25, D star goes down to analog voice and then to P25. D star wants to talk DMR, D star analog voice, DMR out to the network. DMR wants to talk to M17, DMR goes in, encoded in M17's codec to and out. There's only one codec hit, and that's improved our voice quality tremendously. So let's go through an example of D star to DMR. You have a lot of wonderful DMR and D star resources here in Cache Valley. In fact, the building that we're in has one of the DMR repeaters in it. So let's start with the D star side. D star has a reflector system. In this case, I used 29 Bravo, but for the demonstration, we'll use 29 Charlie. It's just a different module. So we start at the reflector. We go through something called a gateway that connects to the reflector. We go through another bit of software that talks to the gateway and does all of that. And then we go through an instance of analog bridge. And what I've showed you here, these are the hardware transcoding sticks that are living at my house right now that take D star's voice and convert it down to analog. Oh, and by the way, if you have questions, I'm happy to take questions at any time. If it's something that is short and we can address it right now, we'll do it. If it's something that I think may take a little bit more time, we'll try to save it to the end. But I'm happy to take questions at any time.
Can't take questions like, how do you come up with all this stuff?
Lots of nerdiness. There are other systems that have implemented similar strategies to this. And so I've taken notes from them and worked with some of their engineers, and we've tweaked this to do our own methods. Some systems use All-Star as a central hub. Some systems use XLX, like we used to do as a central hub, and now we've just iterated on this to see like what's going to work the best for us.
Is this Spencer?
Yes,
Going to the previous slide,
sure.
yeah, that one.
Yep.
Where we have like D-star and the other modes.
Yep.
There's one analog bridge between each of those modes with the reflector.
Yep.
You said there's just one codec. It just needed to go from D-star to
There,
M17.
there's only one transcoding hit. So when I say transcoding, I mean take one codec, bring it down to analog, and turn it into another. So there's technically two encoding swaps that have to happen. Just like if you were to have a person speaking that only knows Portuguese and a person speaking French and a person speaking English, English will use as the analog voice, and the translator can translate between all those three. That's what a transcoder does.
Okay, so then moving to the present slide
Sure.
with that. So where in this picture here do we have the codec and the transcoding?
So that's happening right here. So once we get out of MMDVM bridge, it sends the raw data to analog bridge D-star, and that's what converts it down to analog voice. And it uses these hardware transcoding sticks with that DVSI proprietary chip on it to be able to do the hardware transcoding. Does that?
And then the two sticks there, they for different modes of D-star M17.
Yeah, so we actually use them for, so each of these sticks does one instance of D-star, and we have 3 options for talk group systems, and we'll get to that at the end. So like one of these sticks does reflector 29 Bravo, and another does 29 Charlie, and another that's not pictured here does 29 Delta. So we have 3 different entirely separate networks that can all be used as multi-mode hubs. Does that help? Awesome. Yes.
Functionally, for instance, on our Sunday night digital net, should we be taking a longer pause between things and count on a little bit longer push to talk and so on, so that we can not
Mhm.
miss part of call signs and conversation.
That is very much helpful to do. There, as you're seeing, there's lots of different software bits that all have to come alive all at once to be able to do all the transcoding to each other. So a good best practice for digital voice is always to leave a little bit longer breaks than you normally would to key up, wait a little bit, and then start speaking. So good. I'm glad you brought that up. Thank you.
Spencer,
Yes.
are these radio specific? I mean, you talk Yesu.
Sure.
Do you have
S-
specific?
Some of the digital voice modes are brand specific, and within those brands, some are radio specific. So Yaesu makes models of radio that are capable of digital voice as well as analog, like the FTM 500, the mobile. And then Yaesu also makes versions of radios that are analog only. So if you're looking for a digital voice radio, you want to look at to make sure it actually has that capability built in. And some of these standards, like DMR, we'll get to in a second, are open standards, and so anyone can grab that standard and implement it in their radio. So there's probably hundreds of DMR radio manufacturers out of China by now. So does that help?
Is any tone?
Anytone is a DMR radio. Yep, and it's a great radio. So after we get out of analog bridge, we send all that analog base data to analog reflector. So let's go over some D-star gotchas. I get asked a lot of these questions a lot. So the type of reflector that we use, a D+ reflector, requires call sign registration. If you want to go out to the internet and out to everything else that's connected, your call sign has to be registered with the system. Now what that means for us, we started to bring in a bunch of users and shove them into D-Star who may not be registered with the D+ reflector system. And what that meant was their voice traffic was getting dropped. If someone had previously registered for the D+ reflector system, their voice was getting in. So what we decided to do was use a single call sign. We use Chris Andrus's club call sign, KC7WST, as the call sign that's always sent to D-Star. And I know some people have seen that and they think, oh, KC7WST is talking. Well, kind of. That's just how we have to play this game to get around the D+ reflector registration. Going the other way, from D-Star to everything else, it takes your call sign and attempts to translate it into a radio ID. And if it doesn't, it just falls back to our default ID. If you want to be using the multimode bridge over a repeater, your radio needs to be configured to use the repeater's gateway. Again, the gateway is the thing that gets your voice out onto the internet and into this bridge. And so if you're not using the gateway, you won't be heard on the other digital voice modes. And experts like Ted and Tyler and Kevin and others can help you with the D-Star configuration. Hardware transcoding is required for D-Star to work right. There are some software implementations of it, but it's not usable in my opinion. So that means we need physical server access. So one day we'll get this all moved back into the data center at Utah State, and for now it's running at my house, and it seems to run okay. I'm on gigabit fiber at home, and it's had great uptime, so knock on wood. Okay, let's go to the other half of this now, the DMR side. We're coming out of analog reflector. That's where we left off in the previous slide. So right now we're at analog voice. We go into another instance of DMR transcoding. So now we're taking analog voice and converting it back into digital. And this can either be done in hardware with one of those sticks or in software. And we like to do it in software because then we can have servers up in the cloud or wherever and run this wherever we need to. We go to another MMDVM bridge instance. We go into our XLX hub, and then we're shoved out into the DMR network, which we use. It's called Amcom. It's a newer DMR network that is very supportive in allowing us to experiment with all these bridging modes. And so this is a screenshot of your repeater in this building that's live on Amcom's network. So let's go over some DMR gotchas. There are many different DMR networks. So we in the Utah Digital Repeater Network are transitioning over to Amcom. There's Brandmeister, which is probably the largest, TGIF, DMR Plus, DMR Mark, Free DMR, etc. There's lots. Be aware of what talk groups are available and where. So a talk group number that you use on system A may also exist on system B and C, but they're likely not linked together. So be aware of which network you're on. Users will need to register for a DMR ID to use linked DMR repeaters, similar to D-Star. And the registration process is online. You put in your call sign and something that says, hey, I'm a valid ham, and they give you a 7-digit ID number that you stick in your radio. DMR repeaters use something called TDMA, or time division multiple access. What that does is it logically splits up a DMR repeater into 2 functional repeaters operating on the same frequency. So your repeater here at the SO has 2 time slots, 1 and 2, and both can be used to have simultaneous conversations at once, or you could do data on one time slot, voice traffic on another. You could use both for data. There's lots of options with DMR. So it's important to be aware of what talk groups are available on what time slot. And also there's the idea in the DMR world of static and dynamic talk groups. So dynamic talk groups are available for you when you just key up on it. You could chunk your radio and it brings it up on the repeater. And static talk groups are there all the time, no matter what. So can analog voice fit in? Who's thought that before? Me, I have. What did you notice about this slide and what we did over here with analog reflector? Everything over here is already speaking analog. It's just going through analog reflector and then being shoved into those instances of analog bridge to be able to translate it. But we could take analog directly off of analog reflector, and that's where All-Star comes in. All-Star is a voice over internet protocol similar to IRLP and Echolink, and I think is going to be the next generation of what voice over internet protocols should be. We went over that. The audio quality is extremely good. It is indistinguishable from local analog audio when it's all set up correctly. All the software is open source. It's based on Asterisk PBX, which is actually a phone system. And so when you use All-Star behind the scenes, it's kind of placing calls and using a database of node numbers, which kind of act like phone numbers. And Asterisk has been around for a long time, and they've made a lot of work on making Asterisk run very well and on lightweight platforms. With All-Star, you self-register for public node numbers, or you can use private node numbers without any kind of registration. You can just build your own hardware, put the software on, put in a private node number, and then set up other private nodes and make them link without any kind of registration. There's no keys needed. You don't even, I guess in theory, you don't even have to make sure your call sign's valid. You can just set it up. The hardware, the interface hardware is inexpensive. You can go to the full DIY method like I did. This is a pencil box node that I built that usually lives in my car. I built it with a Raspberry Pi 3, a little bit of interface circuitry. Remember, I'm a hardware guy. I'm not a software guy. So this side of it, I understand very well. All this software stuff that we're talking about, I'm all self-taught. So I don't consider myself an expert in this, in the software side. So on the hardware side of this All-Star node, I chose to use a little cheap $8 Amazon USB sound card. And I did a little bit of audio buffering circuitry for it. And then that is a ripped apart and modified Baofeng BF888. They're a $10 UHF radio, and for this purpose, they work fantastic. They sound great. I actually ripped out the final amplifier in this, so it only transmits about 20 milliwatts, and it's perfect for like an around the house hotspot node. Up here on the show and tell table, I also have some other things. I have a board that we would use to interface a full repeater to All-Star. And in this box up here is a full duplex version of this. So this box is actually full All-Star repeater. It's got 2 radios in it, a little duplexer, and a All-Star controller that is the glue to everything else. And like I said, we can have simplex nodes, full duplex repeaters. You can have nodes in the cloud. You can use USRP, which is an open source, I want to send analog voice over packets. And that's actually how we use it in the multimode bridge. Are there any questions so far? I know I'm kind of going pretty fast paced because I want to leave time for questions, but Kevin.
So in your diagram of all the systems and your encoding,
Yep.
you're going to analog,
Yes, we are.
then to instead of transcoding digital to digital.
Correct.
And
Because,
there's a reason behind it.
yes, there is. You need to have some common ground to be able to transcode. And that common ground is analog in this case. It's just how the software was structured. You can point different instances of analog bridge together and then ship it off. So yeah, we use analog as kind of the base common denominator for all the modes that need to be translated to each other. So good question.
Do you think that's the future?
It's possible to do digital to digital transcoding, but that costs a lot more money. Like, for example, what UCA is doing, the public safety P25 network, they're transcoding between P25 phase 1 and 2, which is totally different voice codecs, but it sounds almost identical. I can't even tell that it's being transcoded because they're paying lots of money to do that all in specialized hardware and software, and we're using more or less free stuff. So this is what we have available right now in the amateur radio world. And there's other ways of doing this architecture as well. XLX reflectors are capable of transcoding. There's URF reflectors, which are multimode. But we like the flexibility of doing all the bits and pieces ourselves and being able to look under the hood. This also has the advantage that if one of these processes dies, it doesn't take out the rest of the modes. Whereas if we used all the transcoding in XLX, if XLX has a problem, then everything is gone. So, thanks, Kevin. Does that help?
Yeah.
Was there? Sure.
Because I know you played around with a lot of ways.
Yeah.
This
Yep.
obviously was making sense.
There was a question over here. Then we can. No, maybe. Okay. Yes.
So in response to your last statement, that Utah Communications Authority network is using digital to digital.
Mhm.
And you
At
mentioned
least that's what it sounds like. Under the hood, it could be, I don't really know what's going on under the hood. It could be just a better, high quality version of what we're doing for free, but they're doing it in a way that it just sounds really good.
that probably obviates my question, so I'll pass.
Okay, great. Anything else? Let's get back to All-Star. If you are interested in building an All-Star node, there's lots of different options for hardware and software. And I'll explain a little bit of the differences in the software side. There's a group of people that have developed All-Star Link 3 and another group of people which have developed a All-Star software base called HamVoIP. They're both all based on Asterisk, so they all behave the same, but you have some different features in them. So All-Star Link 3 is based on Debian 12 and 13, which also translates to like the Raspberry Pi OS, and it can run on lots of different platforms. HamVoIP is based on Arch Linux and also runs on lots of different platforms, but it's a little more limited. It was designed for the single board computers. All-Star Link 3's source code is all completely open source. HamVoIP has some code and some special features that are closed source. All-Star Link 3, because it's running full Debian, has a little bit more overhead. Ham VoIP is very bare bones software, and it's also been very stable. All-Star Link used to not be the stable option, but in recent years, it's become extremely stable, and I now have All-Star Link 3 deployed on mountaintops, and I don't even worry about it. The asterisk processes run as non-root, so like non-admin user, which is a more secure option, but it's less flexible. Ham VoIP, the asterisk process runs as the root user, so it's a little less secure, but it's more flexible because it can access more of the special scripts. In All-Star Link 3, some of the advanced features are left to the end user to figure out how to configure, and they have some great documentation though. And in Ham VoIP, they include a lot of convenience scripts to be able to configure some of the advanced features. And by the way, I'm hoping that I'm sure we can make this presentation available for later. We'll publish it. That was the intent behind this. And so you don't have to try to absorb everything right now. You can go back and look through things. So some analog gotchas, especially when thinking about how to get the analog world into digital voice. Obviously in analog, there's no call sign being sent with your voice. It's just your voice. So there's no metadata being sent. There's no way for us in the bridge behind the scenes to convert anything to a call sign or a radio ID. So you will always appear as our fallback radio ID. It's not a big deal, just something to be aware of. We're only officially supporting All-Star for a few reasons. In my opinion, Echolink has less than optimal audio quality. It works fine, but I think it's not as optimal, and it requires a unique public IP address per node. Unlike All-Star, where we can hide a bunch of nodes behind a single IP address and play however we want. IRLP, the other large contender, has been around for a long time, but it's very tightly controlled by a single person. And I have found that it's not very welcoming to experimentation. And that's their fiefdom. They are totally welcome and absolutely entitled to run it how they want to. Bridges with All-Star are very common. There's lots of clubs and networks that are doing bridging with All-Star, and it's all very well documented. There's lots of how-tos online. And everything with the exception of D-Star can be done in software for free. So if you wanted to right now, you could install Linux on a Raspberry Pi or on a $5 a month cloud server and put an All-Star node in and do 90% of what we're doing with the Utah Digital Repeater Network yourself. It's all available, it's all free, it's all open source. And All-Star analog is the reason that analog can fit in. So, some recap. When we do our multi-mode bridge, we split all the native modes into their own thing so that they can have one-to-one audio to each other. It maintains the quality. I know some argue that the quality is still not that good, but for the sake of here and now, we're saying that's good quality. Then on the modes that need some translation, we shove them all into analog reflector, and then one instance of analog bridge goes out, and everything else is transcoded with only one transcode. And that allows us to maintain the best audio quality that we can, even though we're translating or transcoding. Here is our talk group summary that we have available. So each one of these, 0, 1, and 5, are each an instance of this. And they all translate to different things. So 0, 1 is what's connected to 29 Charlie. So your Sunday night nets, that's what's available for you to talk on. You could pick almost any digital voice radio in amateur radio and talk on that net. We've also found a way with Analog All-Star to link one of your repeaters, the 147.2, to this net. So you could check in on analog to the digital voice net through that repeater. We also have other talk groups. 314900 is where a lot of the DMR users hang out. And then 05 is kind of a experimental place. 0, 0, and 0, 1 on the DMR repeaters are kept as static, so they're there all the time. 0, 5 is a dynamic, so you'd have to key it up and bring it to that repeater, and we do that so people can have an option that's not as busy. We do want to put the caveat there that the digital repeater network is obviously primarily for digital voice nodes, and we put analog in as kind of a backdoor for experimentation. But if a wide area repeater is going to be connected into this, we just ask that you talk to one of us first, myself, Ted, any of the Utah DRN guys, and I'm sure we can work it out, but we just want to make sure that things are kept clean. I think that's it. Yeah, look at that. 29C is busy. I bet you he's not using the gateway because I don't hear him on the other modes. Oh. Okay. Yeah. All right.
So I have a question.
Yes.
And we're just talking about it. I may have missed it, but if we are analog and we want to connect into this, we go through our All-Star node radio, which is the one at Smithfield. Is that correct?
Yeah.
And we have to do something to key it up to connect?
You might. Most of the time it is connected. Right now it's connected and I've been for about a week, nobody's moved it. There's a couple things and Tyler and I built a presentation that shows how to do that. Tyler, tell them how you sometimes check into the D-Star net on Sundays.
I have an app on here called Ammermon, and I connect an All-Star node. I connect to the All-Star node. Do it on my phone.
So which one of those top groups is it connected to?
0, 1, the middle one. So we can do a little bit of a demo now. So I have here my DMR radio. I'm a weirdo, so I like to use Motorola radios. And this is listening to the DMR repeater that's here in the building. So I can key up on DMR. NG6K testing Utah DMR. So what we did there is we transcoded DMR simultaneously to analog voice, which I have connected to my little mini repeater up here. I have it on P25 through one of my hotspots right here and my P25 radio over here. And then D-Star over there with Ted. And All-Star, yep, and through the Smithfield repeater.
He went out one and we came out 4 other places.
Yep. And like, yeah, when you hear them all jump. Okay. NG6K testing on 29 Charlie.
We have to build that into the producer.
Yep. It's about a 1.5 second delay to be able to transcode everything and spit it back out to the network.
Let's turn the volume down on, so that we could do one at a time.
Sure. Yeah. So should we do D-Star?
By the time, I mean, let's say you transmit, we're not in the same room and I hear it. You are a second to a second and a half ahead of me.
Yep.
So if I retransmit soon after I get mine, that's okay because you're done talking.
Right. It's similar to if you have experience using the intermountain intertie. You kind of have to wait for everything that the network to come up and your voice to propagate. And then the same thing happens on the way back. It's a similar thing. It's just happening all in the digital world. So should we try just DMR to D-Star? NG6K DMR to D-Star demonstration. And you want to try going back the other way? D-Star to DMR?
NG6K, this is AC7I.
There you go. Just like that. And so my call sign going to D-Star, remember that caveat, my call sign's stripped away. and we send KC7WST because that's a call sign that we know is registered with the reflector and we know everyone can get there. Ted coming back though, his call sign coming from D-Star goes through the bridge and is found in a lookup table of like 250,000 radio IDs, and it says, oh, here's your DMR ID. Send that out to the network and he can show up on my radio as Ted.
That is something me and Chris came up with just recently. Before, almost every time people coming from DMR, different ones, would come up with the KC7WST call sign.
Yeah.
But now a lot of times it will tell me it's him or whatever.
Yeah, we're working on some, like just in the last week or two, we're working on ways to still put that metadata into different places in D-Star. So like there's a message field where you can put in, hey, I'm on this radio or whatever. And we're looking at ways to be able to stick your original call sign in that message field so you can still show up on someone's radio as you.
Okay, now I'm on the All-Star, which means any that has 2-meter radio can use this. Go ahead.
NG6K testing DMR to All-Star.
This is a C7.
There you go. Yeah. Great. 87 MG. Yeah. Yeah.
Thanks, Mike.
So there you go. I'm glad that worked. That was the most nerve-wracking part of the whole thing. As if that's going to work live. Yes.
Silly question. What's the major advantage of digital radios? So you can use your cell phone to get on phone?
So I forgot, I need to be repeating these questions. So the question was, what's the advantage of digital voice? And the truth is, it's just another fun thing to play with. There are some advantages. If you're, let's say you're on the fringe coverage area of a repeater, where in analog FM, you could still key it up, but your voice really isn't intelligible. Digital voice will work until it doesn't, until it stops decoding. So even with low signal strength, very bad signal to noise ratio, it can still work when analog voice may start to sound fuzzy.
Never hear static on digital voice.
You will hear something we call R2D2 sometimes, and that's when you get little weird anomalies in the voice, and a lot of that has to do with the network traffic in between. So maybe you lose some packets and maybe things get rearranged in the wrong way. And so you sometimes get a little bit of R2D2, but like that.
So one of the other things that you can do on the different modes, like D-Star has a full digital side. They have a thing called DRATs. And I can go look, I can send computer files, I can send pictures. I'm on there's a net that this goes on, that a D-Star node goes on to in the morning. And those guys send pictures all the time while the net's going on. They're sending data while talking because they can do it simultaneously. And the pictures are photo quality, and they're just sending it. They send it about. It's not very fast, but they can do it while they're talking, and you can actually share folders on your computer, and a person can go, if you got a file, they can go grab it, and you can send messages similar to WinLink, but you can do it just right from your computer. You don't have to use WinLink. You just fill it out and send it back.
Yeah. Mm-hmm. I mentioned some of the other advantages, like DMR has that 2 time slot, so it converts a single frequency repeater into 2 logical repeaters. So you could have a wide area talk group operating on time slot 1, and you could keep local traffic on time slot 2, and both of those can operate at the exact same time. There's the, I think the voice quality is fairly good. It may take a little bit of getting used to if all you're used to is analog, crisp, clean analog voice. But there's also like the ease of linking to other things. If I want to link to a different talk group on DMR, all I have to do is key up and it'll bring it to that repeater. And a lot of the digital voice repeaters operate like that. So if I want to talk to someone in England, I can key up on one of their talk groups and likely find someone there. And it's that easy. I don't have to go do a bunch of manual configuration of a repeater to be able to link that way. So good question. Am I missing any questions online? Let's check in on them. No?
Nothing's come through yet.
Okay, they're all asleep.
Pretty good.
Okay, what else do we have? Yes,
So would you kindly review with me
absolutely.
what this duplexer repeater that you made
Yep.
is doing in our demonstrations between you and Ed?
Yes, so I just brought that as another little demonstration of what All-Star can do. So I can bring that up on my radio. And here, like we can do P25 to analog, same time. And G6K from analog. So I just brought that as another method of demonstrating what All-Star can do and some of the hardware that you can build with All-Star. And yeah, yep. And the advantage of having a full duplex repeater is if you need to send link commands or something while it's transmitting, you can, because it's also receiving at the same time.
So is this repeater that you designed and brought?
Yep.
Is it playing a role right now in your communication?
Yes, this is linked to this center Utah 01 right at the moment. So this,
Is it linked by RF? Because I don't see any cable.
it is linked to my cell phone's hotspot internet, and that is getting back into the multimode network. So that has an internet connection, and then it's connected into the multimode bridge, which has access to everything on the 01 talk group at the moment. So good question.
It's very sophisticated.
It can be, yeah. But when you have repeater infrastructure that's already available, you don't need to worry about all this stuff. It's helpful to know what's available and how some of it works behind the scene, but you don't need to worry about building your own All-Star node. We've already taken care of that with the Smithfield repeater. We have other options down in Utah County where I'm from. Other DMR repeaters that are already set up. D-Star stuff that's already set up. So you just need to be aware of what could be connected to what, and then just have fun, play.
Explain what we're gonna do here.
So Ted's holding an important box that I made sure to give him at the beginning of the meeting so I didn't accidentally drive down to Utah County with it and go, oh crap, I should have given that to him. That box has a digital voice modem in it that we're able to plug into an old analog repeater and just like that turn it into a digital voice repeater that's capable of doing multiple modes. So it could be a D-Star repeater, it could be DMR, it could be P25, it can even have all these turned on at the same time. The caveat is only one of them can be active at a time, but they can all be on at the same time. So it's a really cool feature to be able to convert existing infrastructure into something different to play with. Yeah.
Explain to the hotspots.
Yes. So in the digital voice world, some very smart people also came up with the idea of a digital voice hotspot. This one happens to have a built-in battery in it. So this is a Raspberry Pi Zero and a little RF board on top that speaks all these digital voice modes. Actually, something similar to this, it's what's on that box that Ted has that's going to go in the analog repeater.
Is that purchasable
Yep.
somewhere, or
Mhm.
that you built that?
I put it
Some very
together.
smart person.
Someone designed it, built it. I just put the screws in it and put it together. I can't take any credit for this. But this allows you, just with an internet connection, to be able to access not only all this stuff, but all the other network talk groups and reflectors and everything else that all these digital voice networks have to offer just from one of these. So these transmit like 10 milliwatts. It's really just like around your house, but it's perfect for that.
You don't need to be able to hit a repeater that we installed. And if somebody could go, well, I don't really want to be on what that's on. I don't want to go change that. I just want to do my own thing, or I
Yeah.
want to listen to something else.
Like if you want to, let's say you want to listen to a worldwide net on something, D-Star. What's a busy, like 30 Charlie or something busy? Yeah. You may not want to bring that up on a repeater that everyone's listening to. But if you have one of these, you can put that on here and listen to it indefinitely. You're not going to bother anyone else. Not that most people care, but this is your own little sandbox that you can play with.
A lot of people use them when they're traveling too.
Yep.
Talk back home.
Yep.
Do you listen to it through your computer?
Through a radio. Yep.
So that's connecting,
So again, yes, cell phone hotspot.
and then that transmits out onto your radio, whatever.
Yep.
mode you have to be.
So I happen to have this on P25 right now. So let's do a little demo of this. NG6K testing on P25. Oh, it's too close. It's wiping its receiver out. There it goes. NG6K testing P25. So it picks up my RF from my radio, does some fancy stuff, ships it out off the network, and then the place that I have it connected to right now, the 01 bridge, happens to be talking to everything else here in the room. So, but this could be pointed to any talk group, any network.
What is that called and where would you find it?
There's different, so generically, this is called an MMDVM hotspot, a multi-mode digital voice hotspot. There are manufacturers that make them commercially. I'm a fan of the Zoom Zulu Uniform Mic hotspots, and this is one of them, isn't it? This is one of Ted's digital voice Zoom spots that's commercially available. They're made by a guy in California. So this has got a nice big screen on it. You can get lots of call sign information and whatever. And
Actually talk through it a lot, but I leave it on my hooked up, and it's like connected to 29 Charlie, and it's on my desk. And the display will tell me, oh, somebody's talking on it, so I may not even be on the radio, and I go, oh, wonder who's there.
Yep.
And I'll go there, and it will tell me who's there, give me the name. That little white one, probably one of the most expensive ones, but it has some of the transcode stuff in there, the crosscode. And it has a battery in it, so you can stick it in your pocket, connect it to your, make your phone a hotspot, and you can go anywhere with it.
Yep.
Drive down the road and you can key up your radio and talk to anybody, no matter where you're at.
or if you happen to live in an area that doesn't have a digital voice repeater, these are great options. Yeah, so that's made by a company called Shark RF, and it's the Open Spot. They have different models of the Open Spot. So does that help?
Yeah, afterwards I'll come and get
Yeah,
details.
Absolutely.
It's fun to build. I don't, between the two of us, we built two just over the Christmas break.
Yeah.
Two terribly hard to put together.
Yeah, I mean, you buy,
Instructions I put like for the wires, we made that mistake on mine.
yeah, so you buy a Raspberry Pi, you can use the little form factor 02s, and then the hat, I've bought the cheap ones off eBay for $30 and put them on. I have access to RF test equipment at work, so thankfully I can go in and fine tune and tweak things on that most hams can't, but you can get it very, very good, very, very close, even with just the cheap Chinese eBay ones, just with a radio and doing some calibration routines on it. The higher quality ones like Zoom Spot use better components. They're more frequency accurate, so you don't have to fiddle with them as much.
They make Zoom makes small ones that are,
Yeah, kind of like this size, maybe even smaller, because this has a built-in battery that I put in it. But that form factor.
the Shark and the other one, the DV Mega, don't use the Star software. They have their own interface that they use, but
Yep.
they all work and they all do. They pretty much all do everything. Not all of them do M17 yet, but some of them do. M17 is kind of an open source
Yeah.
network that has been developed over the last.
And these also don't do analog voice. You can't buy one of these and have it do All-Star unless you were to build your own digital to analog bridge. You would have to go into one of these on a digital voice mode and then have something else somewhere else that's transcoding to analog. But there are also options commercially available for analog All-Star hotspots too. You could build your own. On the other end of the cost versus simplicity spectrum, there's a group called ClearNode that's making them. And then somewhere in the middle are like nodes called the Brian, which is kind of like that pencil box node that I made with a Baofeng. And there's others that use like Sherry, I think, is one that uses a little modularized UHF transmitter. Lots of options. Come see the show and tell. There's stuff up here, and there's a few more things over on that table by Ted.
And Tyler and I put together a presentation that we'll share on the groups.io on if you only have an analog radio and you want to use the Smithfield repeater, the 147-200, that repeater is kind of a jack of all trades. It can do a link to Mount Logan, it can do Echolink IRLP, and it can do All-Star. So there are some steps you might need to do if it's not already in that mode.
Yep.
And I will show you in that presentation, it shows how to make sure it's in that mode, and also it shows you how to get into the web page to allow you to make sure it's connected and show them what the All-Star, what talk group the All-Star needs to be in.
Yep.
So the bottom one, the ASL.
Is All-Star Link. Yeah.
That is, you have to look in there, and on the top of you get that page, you type in that number and you hit connect. I put it on permanent, but you can go in there also, and there's all sorts of talk groups on All-Star that
Yep.
can be really busy, and you'll get
Yeah.
guys from back east to Europe.
And the audio quality on All-Star is analog audio, so it's like you're there with them on the same repeater.
When you're on the repeaters, it's connected to that, and so anybody, you're not. Right, so anybody that can talk on the repeater could be there, and
Right.
we're only gonna connect to that one talk group, but there could be, you could go to a talk group on All-Star that may have 50 different repeaters on it, and so there's, just like all of these, when you go, you're going to a data center where a bunch of radios are all tied together, so normally you're not talking person to person, you're talking person to a central area that may have multiple groups, just like this.
Yep.
That we're bringing people from all over the world into one center.
Great. Any other questions? Anything from online?
Nothing yet.
No? Yes, over here.
So, if I may,
Sure.
I always like to think of other things. So this question is different from your presentation, but
Okay.
I wonder if it's related in some way. At a very simple level, probably 20 30 years ago, I forget, the FCC allowed FM broadcast stations to transmit a digital code.
Mhm.
And I'm wondering if that digital code has any relation to what we have here in the presentation.
Yeah, so that digital code is transmitted in the audio spectrum that is filtered out by your car's radio. And that digital data is probably going to be pretty similar to the digital data that's being sent with these digital voice modes. So it's just, its role is to send metadata. So in that case, it's sending maybe a station call sign, maybe what's playing. In this case, we're sending a station call sign, and maybe like D-Star, you can send a location along with, you can actually do like APRS over digital, and that runs in the background and is sent in that metadata. So yeah, it's similar. Good question. Anything else? Ready to go home? Yes.
So, look at these talk groups, and I know
Yep.
you said 5 is kind of a test playground.
Uh-huh.
But when we look at 0 and 1, are there any real purposes, any thought there behind it?
It's kind of just where they started as. So 0 started from the DMR world. In a couple years ago, we were very heavily invested in the Brandmeister DMR network, and we have a statewide talk group assignment, 3149. Now, somewhere along the line, the Brandmeister admin said, hey, we don't want people to talk more than 10 minutes on a statewide talk group, even though the state admins are the ones adminning that. Brandmeister just said no. And then Brandmeister said, you can do whatever you want on a 6-digit talk group ID. So we use 314900, which happens to be a repeater ID that's on Ensign Peak that we own. About a year later, after setting up all this multi-mode bridge stuff, Brandmeister said, no, you can't do that anymore. Cut you off. And so they started blocking people without any warning, like myself. They just yanked my radio ID from the network temporarily and said, I apologize not to do this again. And then it was at that point that we started building a relationship with Amcom DMR. It's a US-based DMR and Yaesu Fusion network. And their admins have been great. I talked with Curtis, the DMR admin, on the phone. They have a 1-800 number you can call for help to get connected or whatever you might need. And so we have transitioned over to Amcom DMR because they allow all this experimentation. They really allow us to do what we want with resources here in Utah. So to summarize all that, Utah 00 started from a DMR base, and then we built it off there. 01 started off your D-Star base. It kind of started off of 29 Charlie. So a lot of users you'll find there are D-Star users. Everything's still available. 00, a lot of the users happen to be DMR users, but everything else is still available. So does that help?
Yeah, it helps. I just didn't know if we had, you're trying to build into use as they get
No.
easier. If there's like, which one do you monitor? Which one?
So our, the D-Star reflectors have a bunch of different modules. The main ones are A, B, C, and D, and they're just other top paths.
Yep.
And so that's why we're using those. And right now, A doesn't have.
Yeah, across the board, we kind of leave A and 3149 as their standalone modes. So just D-Star, you just want to talk D-Star, that's where you go.
So originally, we stayed away from 00 and we built it on 29 Charlie because we had the net there. And then they connected in 00 and so on Wednesday nights, our local repeaters automatically switch over to 29 Bravo because Wednesday night at
6 p.m.
6 p.m. there was a DMR net for Salt Lake area or came out of Salt Lake.
Yeah.
And so that brought it in and we connected into that. And so if you listen to anything on this bridge on, and go to that correct talk group, you'll hear that
Yeah.
next Wednesday night. And then our repeater, a lot of times it's on 29 Charlie, because that was kind of the old time statewide, most of the D-Star nodes that were on the gateways throughout the state were on 29 Charlie. And so that's why we
Yeah.
did that. So the Sunday night net, you don't have to do anything except for go to the repeaters. They're automatically gonna switch for you, because you can go steer any of these repeaters to any reflector you want at any time. But it's going to try to put it somewhere at a certain time, a certain day, so that it will be available for the net. In fact, in the mornings, our repeater goes to on D-Star repeaters go to 35 Charlie, which is another net that happens every day, every Monday through Friday.
Yeah.
And it's not on this bridge, so it's just, it does have a connection to an XLS repeater too, but so most of the time you don't need to figure out how to do anything but connect to a local D-Star repeater, and it's gonna do what you want. All-Star, it may be there, but you may have to put it.
And we put a lot of this together so to take a lot of the guesswork out of having a common place to talk. So like these hotspots have built into them some of these capabilities. Ted mentioned that. So if I wanted to, I could configure my hotspot to talk to my DMR radio over RF, but then go into a Yaesu Fusion network. It takes some extra configuration. The goal here was we do all of that for you. You just point your repeater, your hotspot to the mode, and then we take care of all the translation for you, at least in these 3 locations.
We do have one question online.
Yes.
N6 UTC says, will Wires X be used in the future?
Yes, that's one of the plans. I got to talk with John at Amcom. He's their Yaesu Fusion expert, and we will eventually bring Wires X into the fold as well. I have a Yaesu DR1X repeater at home now that I can use as a test platform for Wires X, so we're getting there. Yes, so Yaesu Fusion, their digital voice mode, Yaesu came out with a proprietary way of linking digital voice repeaters together called Wires X, which is actually an iteration of an old analog system. They now use it for digital. You have to buy their hardware to be able to link to their reflectors, and it is, for the most part, their proprietary little fiefdom that they play in. There's also open source versions of these reflectors, and that's what YSF is, Yaesu Fusion reflectors. The Yaesu Fusion reflectors are available on hotspots and other multi-mode repeaters. They cannot natively talk to each other, even though they are the same format. There are different ways of linking them together. Some people have figured out they figured out the reverse engineering of Wires X and can do the bridge in software. We don't have that capability yet. There's ways to do it over RF. You could actually put a hotspot on a repeater frequency and let them bridge over RF. And there's other ways. We're going to work with Amcom, the DMR network guys. One of their admins, John, is a Yaesu engineer. So if anyone's going to be able to, and they've already figured out this for other people, we just have to figure out how we're going to implement it. It's very smart people that I don't have the expertise in that area. So thanks. Anything else online?
No, not yet.
Okay. Cool. You ready? We'll leave all this stuff up here for show and tell. And
Okay, we gotta take a picture of everybody, okay? And then, Endall, thank you. Endall, who asked that last question.
Can we trade the microphone? Sorry.
Oh,
Yep.
I'll say hi to our friend Endolf, N6 UTC. He works for Yesu. He's in Long Beach, so he's a friend of ours, and good to have you on, Endolf. All right, I'm going to set the mic down. We're going to take a picture of everybody, so make sure you can see my phone, okay? Hold on. Well, that's bright. All right. Ted and Tyler, you're going to and Spencer, move over in a bit so I can get everybody. All right, there we go. Yep, I've got everybody. All right, everybody say cheese. Cheese. All right, everybody wave. Wave. All right. Hopefully one of those will be good. All right.
Where will we see that?
That's a good question. On Facebook at least, and probably in the newsletter. Yeah, it goes to Google, my Google poll. Does anybody have anything to bring up before we close? Okay, Tammy has some refreshments there. I apologize, the club store isn't here. It has to do with losing my truck key. So, yeah. Anyway, have a good day, and we'll mingle for a bit. And Spencer's here to answer any deep questions you have. Thank you all.